Okay, I'm going to quickly show you a demonstration of this Desmos activity and the concepts that are taking on place in this. So we have an equation is like a balanced hanger. So you see, we see this situation, it's in balance. The balance point represents the equal sign, and the two sides of the hanger represent each side of the equation. So here, what we have to try and do is try and figure out how heavy must this X thing be in order to keep this side in balance. So since we see 6 and 6 and 6 and 6 and 6, there's 5 of them. So I think that X is 30. So if I type in 30 and try it, it will let go. And if it's in balance, it will give us a little check mark. Now this is actually representing an equation. So the equation here would be X on the left side, and then the balance is the equals. And then over here we have 5 sixes, which is 30. So we would say that this hanger is can be represented with the equation X equals 30. And we get the green light. Here's another example, except this time I've got some on this side and some on this side. Well, if I'm trying to figure out what X is, I'll give you a second to talk to your elbow partner to see if you can figure out what X is. Okay, let's come back and see if your conversation was good. So since we have 3 over here, if I took off 1 and 1, it would still be in balance. Take off another 1 and 1, and take off another 1 and 1, then that would mean that this X is equal to the 2. Or you can imagine if I had 1, 2, this is 1, 2, 3, 4, 5. This is 1, 2, 3. That means that the X must be 2 in order to keep it in balance. Let's try it. Excellent. And you can see what happens if you get it wrong. We would say that this is too heavy and it's not in balance, but we want it to be in balance. This time, the equation that represents this is X and then 3 more. So we would say X plus 3 is equal or balanced to 1, 2, 3, 4, 5. Oops, I'd put 3 instead of 5. Okay. And if you think about how you solved this equation for the last couple of days, to isolate for X, we took away 3 from both sides. Well, if we take away the 3, 1, 2, 3, 1, 2, 3, we would just be left with X equals 2. All right, let's look at the next activity. And this time, you see that I have 2 X's over here, and then just one big block that's worth 8 pounds. Well, how much would each X have to be if they total 8 pounds? That must mean that they're both 4. So let's test that. And it is in balance. So what equation is this representing? So this is representing an X and an X. That means there's 2 X's on this side, and it's equal to 8. And again, if you think about seeing this equation that we've solved in the last few days, to solve it, we would divide both sides by 2, divide both sides by 2, because this X is split up, or the 8 is split up in into the 2 X's, so it must be divided and divided. We get 4 in each. Here's another example. Oh, actually, I'm going to scooch ahead to another one. Here's an X and an X, and then 5, 5, and 5, and 5. That's 20 in total, and it's divided between the 2 of them, so I think X is going to be 10. Again, let's write the equation for this. 2X equals 20. 2X equals 20, so these 2X equals 20, and therefore each X must be worth 10. And finally, in the third Desmos activity, we go a step even further. Here is, actually, So here, you see I've got 3, 6, 9, 12 on this side. And here I have X plus 3 and 3 and 3. That's a total of 9. So I would say that this one is 12 is equal to X plus 9. And if I was to solve, it's just like the ones we did in the other activity. Think about what we would do here. I've got 12 over here and 9 here, and I want to only look at the x. Well, I can get rid of, if I get rid of one 3 in order to be in balance, I have to get rid of another 3. If I get rid of this 3 in order to be balanced, I have to get rid of that 3. And this, I got to get rid of this. So in total, I've gotten rid of the 9 here and 9 over there. Well, that's just like my math where I'm supposed to subtract 9 from both sides. And when I subtract 9 from the 12, that leaves me with just x equals 3. So let's see if that works. And it is in balance. Here's another example. 2x plus 2 more 2, so that's 2x plus 4. That looks like this one is equal to 2, 4, 6, 8, 10, 12. Yeah, I think that's 2x plus 12. Think about how we've been solving two-step equations. Well, the same concept is happening here. If I take away a total of 4 on this side, in order to be in balance, I would take away 4 on this side. So minus 4, just like I had done before. That's going to leave me with 8 on this side, which is divided by 2x. So I'll just need some space over here. So 2x equals 8. It's like the 2 cups covering up 8 cubes. Divide both sides by 2. Divide both sides by 2. X equals 4. And you can visually see that if I take this x, it equals 2 of these, and this x equals 2 of these. That means each x must be equal to 4. So this visual of the hangers is just meant to help you visualize the algebra that we've been doing in class. When you go off and do these Desmos activities, you don't necessarily have to write this stuff out like I did or circle the stuff. You just need to see the logic that's happening behind and recognize that the algebra matches the logic, and then just go off and put in the answer. I just wanted to demonstrate how these hangers situations are modeling the algebra that we've been learning. Good luck.